Thank you all for joining us for another great episode of Becoming Multiplanetary. I am one of your co-hosts, Kage, and I'm now going to hand over to our next co-hosts to introduce themselves.
Hi, my name is Rich LB. I'm also a co-host here on Becoming Multiplanetary. This week we're going to be talking about Moon, Mars and more, and also part 2 of Space Stations. And next on the show we have...
Hi, I'm Mikko, the host of Deep Dive Fridays.
Hi, I'm AnotherSpaceNut.
Hello everybody, I'm Benno. Great to be here at Becoming Multiplanetary. I'll be a guest speaker today.
Hi, I'm Framric, and I'm pleased to join the Becoming Multiplanetary podcast today. I'm also proud to be a patron of Total Space. Thanks for having me.
And thank you all for joining us. Yeah, so as Rich mentioned, we are talking about Space Stations Pt.2. So in our last episode, we had Felix from What About It, where we were talking about space stations, especially the International Space Station, and where that's taken us so far, or also where it's not really taken us so far. In the past 20 years that the International Space Station has been in orbit, in low Earth orbit even, we have, as was stated in that show, taken baby steps when it comes to the advancement of various things that we've learned from being in orbit, from living in space for extended periods of time. We've gathered a lot of information from it. We've done a lot of science. A lot of things have been learned from it, but also we've kind of plateaued, it seems, in a way that we haven't gotten to much more advancement. We haven't learned, for example, how to live outside of the protective magnetic shield that the Earth provides for us. And so in this week's episode, we will talk about what's next in space stations. How do we go beyond where we've been, and what can that bring for humanity? So first, Rich, what are your thoughts? What are the next steps for humanity in terms of space stations?
Personally, I think that really we should have if we could just clone Elon, that'd be great. Because if we had some entrepreneur like Elon just come in and disrupt the industry, create another startup just for space stations, that would get it done easy. But what we really need to do is look at the space station technology that we have and do a review. Because we've learned from the space shuttle program before that whilst the space shuttle was a reliable workhorse when it was in service, we've learned that over the years, technology gets better, engineering is more complex, and we can do better things. So really, there should be a review every so often, maybe every decade or so, to effectively go back to the drawing board and see if there's a better way of doing these things with the new technology available. What do you think of that?
Kind of like the iterative approach that that SpaceX has taken with the Falcon 9 and also lately with the Starship. Is that what you mean?
Yeah, and I mean, because they have all these launches going up, they're going to be becoming more regular, hopefully. And when the Starship becomes a regular launch as well, then we'll be able to deploy iteratively through repeated Starship launches, so we can test different modules, different designs, by just simply launching them up on a Starship.
Not necessarily even a Starship problem. Jeff Bezos with Blue Origin, he's trying to commercialize low Earth orbit with space stations. It's not necessarily a strictly got to be an Elon thing. Now, I've outspoken a few times about Blue Origin. I've had stabs that they haven't actually made it past the Kármán line, but then at the same time they are targeting commercializing low Earth orbit with dreamers like the Gateway Foundation for their Voyager space station and the like. They're trying to achieve these bigger space hotels.
Well, I think they have made it just slightly past the Kármán line. Only just.
Yeah, they've been in space, but not on orbit.
Fair point. Yeah, true.
The cool thing is Jim Bridenstine was going about getting American rockets back and launching them from American soil. They've had that destination since 2011. So I guess without the ISS, that motivation would have been lost a little. It's interesting to see now that they've finally got that going on again, that we're looking at an upgrade or something new.
Speaking of the ISS, we know that, as I've said in previous episodes, other than the official extension to 2024 and the unofficial extension to 2028, now is the time to really be looking at creating another space station with newer technology. And with this, there is kind of that concept happening already with the Axiom space station. They've said that once the ISS is decommissioned, they're going to leave the Axiom up there and then build on that, I think, if I'm correct, Mikko?
Yeah, that's the plan. I think it would be in 2028 or something like that. So they would add few modules to ISS, and then the modules would separate and rest of the ISS would deorbit.
And I mean, if anybody listening wants to prepare themselves for a good deorbit and understand exactly what a deorbit consists of, it's not the first time we've deorbited space stations. Like, smaller craft have been deorbited, and it usually makes for a good show.
Well, that's right, yeah. The Mir space station deorbited about 10 or so years back now, I believe.
The Bigelow space capsules and what happened with that company is a bit sad. I don't really know the ins and outs details, but it was really positive what was going on there with those radiation-proof capsules. I was hoping we'd see something similar to the ISS being built out of Bigelow capsules completely, but something's happened.
Speaking of the Bigelow capsules, Framric, are you aware of any radiation protection procedures on them?
I think I mentioned in a previous episode that the Bigelow modules are specifically designed with a proprietary Kevlar mix. The ISS at the moment has some additional shielding, polypropylene or polyethylene, I forget which, plastic blocks basically, to add an additional protection to cosmic background radiation. They've got the Soyuz available as a solar storm shelter, but the Bigelow modules are purposely designed with a shielding mix as part of the module. And I remember seeing a concept design which actually had a fairly simple steel truss framework or a metal truss framework with a series of Bigelow modules around the outside, and it was a rotating space station design. And my thoughts are, SpaceX is trying to perfect the Starship as a cheaply produced, mass-produced rocket. The idea is you get something that's just so easy to churn out, boom, 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 boom. Mass production starts to work. It's a bit like the Tesla production line. Is it possible we can do something the same with basically a truss framework, Bigelow modules, set it up spinning, and then park it in low Earth orbit or Lagrange points or lunar orbit, and there you've got, a mass-produced space station rather than something specific like the Lunar Gateway is supposed to be.
So you talked there briefly about Lagrange points, Framric. Now, from what I remember of your last discussions, you've said that when you place things outside of the Van Allen belts, they are definitely going to need more radiation protection. Now, is our Lagrange points out with the Van Allen belts?
Yeah, the Lagrange. Well, there's obviously several Lagrange points. So you've got L1, L2, L3, L4, L5, depending on where you are in the Earth-Moon system. And there's certainly L4 and L5, which are basically stable points between the Earth and the Moon. Very nice places to put a space station. You're outside the Earth's magnetic field, so you're effectively fully exposed to cosmic background and solar proton events or solar particle events. So building a space station needs to have everything else we talked about previously, life cycle support and also radiation shielding built in as part of it. But that's the challenge of building a space station, I guess, isn't it? It's building it so that people can live and work there, can respond to maybe significant events. I mean, Concorde used to have a radiation alarm on it. It used to fly along, and if that alarm sounded, they'd have to reduce speed and lower altitude because of a solar particle event. So you need that kind of philosophy set up for a space station complex as well.
So you mentioned there that one of the Lagrange points sits between the Earth and the Moon. Does that make it both geo and lunar stationary, as in it always sits in the middle between the two and it orbits as the Moon orbits as well?
Yeah, you're testing my Lagrange point memory. From memory, it is L4 and L5 are completely stable. They're ones where you have points where you could park it in that particular orbit and it basically maintains itself. From memory, the L1, 2 and 3, you have to then do some kind of station keeping. One of them's behind the moon in a stable orbit, one's the other side of the Earth, so you're in permanent sunshine. But I'd have to go back and look at my solar mechanics or Earth-Moon mechanics again to be absolutely sure.
Oh, that's fine. But what I'm saying is, if it is in that spot, the sweet spot between the moon and the Earth, it could effectively act as a comm relay as well between any lunar operations and Earth operations.
Absolutely. I mean, if you want a CIS lunar economy up and running, you could have something in lunar orbit, but actually having the Lagrange points as well are absolutely superb areas for building a factory complex, for example. Take processed material from the moon, throw it up on a mass accelerator, do some processing in Lagrange point area, rather than cluttering up low Earth orbit even more.
So since we're on the topic of Lagrange points and establishing things there, let's talk a little bit about the Lunar Gateway. In the last episode, I kind of went on a bit of a tangent there about Lunar Gateway and how I think that it's technically not been canceled, but if we read between the NASA lines, and especially the Congress lines, it looks like it could be in the not-too-distant future. So back in, I believe, March of this year, NASA had removed the Lunar Gateway from its, quote, critical path to return humans to the moon by 2024. And that could effectively be the death sentence for the Lunar Gateway. Now, there are still plans in effect for the Lunar Gateway through 2027, including several SLS launches, Orion launches, various other things to assemble it, and to even staff it with humans, but that remains to be seen at this point. Since it's not on that critical path, who knows what's going to happen with it. But that being said, my argument in the last episode was that if it does actually get canceled, I think that would be a critical mistake for making humanitarian multiplanetary, especially if we were to go in a direction of learning how to live far away from the Earth while still having the general safety that the distance of the moon provides us. Because if things go wrong and people need to come back from a lunar gateway, it only takes about a day or so for them to make it back here. But it still also provides a good opportunity, kind of building on those baby steps of the International Space Station, building on that to learn how can humanity survive outside of those, outside of the Van Allen belts, where they don't have the protection of Earth's magnetosphere. And that's where we could see things like, for example, the Bigelow modules have a real test for can they actually protect humans in a long-term duration of exposure to cosmic radiation and various other events. And putting one of those on the Lagrange point, for example, could be a good way to test this. It might be a little bit difficult to get to them because getting to the Lagrange points takes a fair amount of delta V from my understanding. But still, that gives us, I believe, a good way to learn and be prepared for much further distances away from the Earth. What do y'all think about that?
Building on what Kage said there for a second, Framric, do we have ways of testing these sort of Bigelow modules on Earth to see how much radiation they can absorb? Like, what are the procedures for testing things like this on Earth?
Oh, absolutely, yeah. I mean, what you do is you design the radiation detector you need to detect cosmic rays. So that's one of the sort of topic areas for a number of space agencies, is exactly the type of radiation and the detector you need. The Germans landed an instrument on the, I think it was Chang'e 4, up on the moon, and were able to detect the cosmic ray background with a bunch of detectors quite realistically, and know the radiation dose rate and what it is on the moon. But once you Then you expose a radiation source outside the module, you put your detector on the inside, and you see how well it attenuates it. So sort of thing you do in a testing laboratory quite easily, and that should give you a good confidence that the material you make your Bigelow space module out of will actually attenuate the radiation sufficiently.
So you basically just bombard it with a radioactive source.
Yeah, it's what people do all the time. If you want to see how good a weld is on a piece of steel pipe, you stick a piece of film one side and you stick a radiation source the other, and the radiation travels through the weld and the steel pipe. You look at the film and it tells you how good the weld is. You can do exactly the same thing with a space station module. Radiation one side, generated artificially, whether it's a neutron source, for example, chuck a few neutrons through there, or a high energy linear accelerator, and then you stick your detector on the other side and see how well that module is shielded.
But it's not only the radiation, but many other factors. Take, for example, the psychological factors of being further away from the Earth. You still have it within visible distance, but you don't have that. Safety mindset that if anything goes wrong, I can just float really quickly into one of the escape modules and I'm back on the surface of the Earth within a few hours. That just wouldn't be the case in the moon. You would have a lot of additional factors that go into that. Well, first of all, getting to the escape capsule, which same thing on the ISS, but then now you have to be in a escape trajectory in order to make it to the Earth. So what happens if you're coming around the moon and you're not at your escape trajectory? There are so many other psychological factors that go into that, beyond just the radioactive factors, that would make it a more well-rounded test, I think, for how can humanity survive outside of the safe embrace in Earth's bosom.
That's the cradle quote there, Kage, from Elon.
Oh, I used that one intentionally. I was building that one in my head as I was talking.
I was just thinking now, everything changed with the whole Artemis thing. Bridenstine came in. We've all been excited about the parallel with SpaceX. Now we're seeing SpaceX just pushing for Mars. And the politics have got in the way again with NASA. And it's like when I hear someone tell me, oh, they're not going to land on the moon directly, they're going to go to the gateway first, have the lunar lander board the gateway or dock with the gateway, then go on board and then lower down to the surface as that safety cradle thing you're talking about. But when you look at Mars, you think, well, the lunar story is not really a stage point that's required. It's more of a rehearsal of expanding out. But yeah, I think the gateway or a system like that would be very helpful, but it'll cost a lot more to sort of double handle those astronauts each time. But it will ensure probably a cleaner settlement in the long run. It's just that I just wonder whether we should be just going straight for Mars, so the moon seems like going to the post box in the morning.
Well, this is what I mentioned in the last episode. I look at going to Mars in I feel like I try to look at it in a similar way to Dr. Robert Zubrin, that there are so many risks that we really need to focus on before we can actually make this a reality. A lot of people talk about, let's send humans to Mars, but there are so many risks involved in that, and that's where, as I mentioned in the last episode, I think we need to slow down before we speed up. That before we actually throw human bodies at Mars and take those serious risks, we need to evaluate those risks in a more safe environment, or a safer environment, of put them in a space station orbit around the moon where they would experience similar effects, have similar psychological disadvantages and so forth. Evaluate those, learn from those, and then once we have everything figured out, then take that risk. Take that big, bold risk of sending humans to Mars. But until we know what we're doing, I don't think that it's a safe bet to do that. I mean, look at, for example, before we built the International Space Station, we had many other different space station attempts. We put humans in orbit for extended periods of time before we decided, yeah, I think this is safe. We can probably do this for real this time. We should probably, I think, apply that same logic to sending humans to Mars. Do a little bit of some testing more locally first, and then send them out.
I've got a question for you guys. So, build a space station. Do you treat it like a cruise liner, where you've got a lifeboat or life-saving equipment per person? So the ISS at the moment limits 7 astronauts because that's the I can evacuate back to Earth philosophy. Or do you treat it more like an aircraft where you don't give each passenger a parachute, but you accept the fact that the risk of failure is very low? Because if you put a space station around the moon and you put 200, 300, 400 people on, are you going to provide them with 400 individual capsules or 4 starships of 100 people each? So what's the fallback? Do you rely on no failure, or do you provide an escape mechanism?
Ooh, now you're getting into some juicy philosophical questions. That's a good one. So, I guess it looks. I guess it depends on how you look at it. If you go for more of a slow, test every nut and bolt kind of NASA approach, then perhaps you could take that aircraft mentality and only have a limited amount of lifeboats, as it were, or life ships. I guess maybe would be the more correct term. But if we're looking to go for speed here, of having people in space stations much further away from Earth, or spaceships much further away from Earth, then you would probably want to go for something where every life could be saved, that there would be a escape mechanism for every single life on board. So I guess it really just depends on what is the development procedure. Are we going for the slow and steady, test everything, make sure that it's all perfect, or go for the iterative approach? Some of this might fail and we need to have an escape plan for every single person. I'm not sure on that one.
I mean, my thoughts are multiple redundancy, which is the SpaceX approach. So you can try and go very slow and steady and guarantee no failure, which is quite difficult to do. Or you do, like we do in the nuclear power industry, you provide multiple systems of safety. So if that's the bit that could fail, you put 4 of them in, or 6 of them in. So you don't need 400 lifeboats for 400 people, because actually what you do is you back up your life support 4 times, and you try and make sure that catastrophic scenario is very, very low risk.
So then what you're alluding to there, if I'm correct, is have less lifeboats, life ships, and just have much more redundancy for the primary space station's life support itself. Is that correct?
Yeah, because sooner or later we've almost got to leave the cradle. You're going to get further and further away from Earth. Mars is a toxic environment. We can't survive there. Therefore, you need to plan for multiple systems of redundancy to keep you alive. Once you're down on Mars, or even in Mars orbit, you're not going to survive. If you've got to evacuate in a lifeboat, where are you going to go? So my feeling is multiple safety systems, redundant ones, to keep you safe, and then that way you don't need the lifeboats.
That's an excellent point. Yeah, that's true. And that would also be true, especially if you have, if it's not just Mars, but also if we were to have space stations in orbit around other places, the Moon, or even Venus, floating in Venus rather, you would need to have something to make sure that since weight is a crucial factor there, that you would be able to sustain all the lives on board as best as physically possible should any one thing fail.
Fremrick actually brought up something really interesting in the chat earlier, saying that if you have a space station and it's in an orbit, let's say between 2 celestial bodies, in this case, let's say the Moon and Earth, for instance, is it still a space station or is it a spaceship?
Yeah, so Buzz Aldrin came up with a concept. I mean, I think it was earlier than him, but he's come up with a very good one called a Mars cycler. So there are a number of orbits where you could set up a space station, rotating, microgravity, well shielded, lots of life support, and you set it on a trajectory between Mars and Earth. You get it up to speed or velocity, and it will loop between Mars and Earth. Now, is that a space station or is it a spaceship? But what you could do is you send a craft up from the Earth to it, you do a reasonably safe, comfortable journey to Mars, and then you do a landing craft at the other end. So my question was, is that a space station or is that a spaceship?
Technically, from the definitions I've seen, a space station is a large satellite equipped to support a human crew and designed to remain in orbit around a planetary body for an extended period and serve as a base for launching exploratory expeditions, etc., etc., etc. So, one of the other things that I've seen as a definition there is that space stations tend to lack major propulsion and landing systems. So then it would beg the question of, well, if you have something that people would live within that's in a Lagrange point, it's not technically in a orbit, so to speak. I mean, unless you're starting to get into like a three-body problem. So is it a space station by definition, or do we need to change the definition of space station?
What I was wondering about was, like, how much of the old school exploration discovery vibe do we need to take from ourselves? Like Sir Edmund Hillary, the old explorers, the old days where they didn't give a crap about how dangerous things were. They just nerves of steel and bodies of leather skin. I don't know what it takes to do it, but there's serious guys on this planet that could probably make mincemeat out of these space missions. They just need to learn how to use the equipment. And sometimes I wonder, like, are we all just that bit scared and we should just observe and report for a while? I've watched for 40, nearly 50 years now. 45 years I've been watching. And I missed out on Apollo 11 and I'm just like, what's going on? I'd really like to see a plan go down where they talk about joining forces and the politics just don't get in the way, so we can really sit down and talk about what's going on. It'd be really great. We're so close. I think SpaceX are going to just end up personally. There's a guy, I don't know if he's German or something, but he can handle the coldest temperature on Guinness Book of Records. So you got guys that can jump into the Antarctic waters with shorts on and get out going. That was very refreshing.
But one of the things, I think what you touched on a really important point there, and that's that there's a lot of politics that's involved in this whole thing. That when it comes to where, how can we have that explorer mentality again? We really have to get past the politics that's involved in that, and since its very inception, space has been political, and I think that that's even the whole reason why we've had the International Space Station be as amplified in importance as it has been in the past, is that in order to resolve those issues that have long plagued the United States and Russia, that have plagued international relationships in many countries, the International Space Station has kind of acted as a space Switzerland, was the term I used in the last episode, where it's a place for no politics, for everyone to drop that and to work together for the betterment of humanity. And that only goes so far because politics also is where the purse strings are held, and if we are to finance, especially at a government level, finance something going to Mars, having that kind of explorer mentality again, we also need to be ready as a general people to accept the risks that come with that. We kind of did back in the 1960s and 70s with the Apollo program, where there were many risks involved, and people knew that it's entirely possible that with each and every one of these Apollo missions, somebody, the astronauts might die. They might not make it back to Earth. They might, their bodies might be left in orbit around the moon or left on the moon. And those are real risks, but they're worth taking. And I don't know how we get back to that mentality. Back then it was about nationalism. Nowadays it needs to be about the betterment of humanity. It's kind of difficult to get us to that mentality, I think, again. But if we were to get to that point, I think we could get back to that explorer mindset of take those risks and say, screw it, let's just go for it. Let's throw human bodies at the problem and see if they survive. Maybe that's a little bit more, a little bit too strong of a phrasing of it, but you get the idea.
That's exactly what I'm talking about. Like, it's just a what if, if there was new astronaut programs and new space training stuff, new opportunities for people to look at it, and then you've got every one of those people looking over the proposals and the ideas that make them feel as like they could do that, they're comfortable with doing. And then how SpaceX worked with Bob and Doug on the Crew Dragon and having them hands-on with everything is pretty much what I think has to happen with the commanders and the pilots. With all these plans and all these things, you need to get these guys hands-on training to become so familiar with the technical aspects of the mission and what technologies are available to that. The rest can be thought about enjoying the experience, because all I hear from these astronauts that went to on the Apollos was they were so busy doing everything they were asked of that they didn't really get the time to like say space tourism would, to sit back and just enjoy the view. There's a lot of work to do in survival. So the idea is if you can train up programs and invent new ways for people to get comfortable with the idea of going rocket, for instance, 90% of people out there would be terrified. So this is where Elon's going to hopefully change the mantra of that.
So we've talked a lot about the International Space Station and even having a space station in orbit around the moon or in Lagrange Points around Earth and the moon, and maybe even a little bit about potential space stations around Mars. But one of the things that I think often goes overlooked is, what about Venus? So Venus is a lot closer to the Earth than Mars is. It takes much less time to get to Venus than it does to Mars. If there's anything that goes wrong in an orbit around Venus, or especially in a space station floating above the clouds of Venus, then it would take less time for humans to get back or to send emergency materials to them. And NASA has even explored this concept. So the Systems Analysis and Concepts Directorate at NASA Langley Research Center in, I think it was around 2014, did a conceptual spacecraft design called HAVOC, or the High Altitude Venus Operational Concept. And the idea behind this was that it would actually float above the acidic atmosphere in Venus, because as some people may remember, many moons ago, Russia sent several probes to Venus, and they only lasted a couple of hours on the surface because, well, for one, the ground atmosphere is extremely acidic and very toxic. And it's also 92 times greater than the surface atmospheric pressure on Earth, as well as incredibly hot. It's about 462 degrees Celsius on the surface, and there's a lot of volcanic activity and so forth. But regardless of all that, there does seem to be some possibility where we could float a space station on the clouds of Venus, if not just put one in orbit around Venus. Framric, would we have the possibility to survive as humans either in orbit around Venus or in a floating space station above the clouds of Venus, especially given the fact that it's closer to the sun? Does that change anything in terms of the safety margins that we need to think about?
Yeah, I don't think it's a problem being closer to the sun. I think the challenge of Venus, as you pointed out, is the huge gravity and temperatures. So you could put a space station in orbit around Venus in the same way you would around the moon or Earth. Same protections needed. But that challenge then is getting crews safely down into the atmosphere and back again. Really good concepts. I mean, the HAVOC concept is amazing. You end up with a floating science platform in the atmosphere of Venus. So don't think that's the issue. I think the main thing is just that setting up the space station in the right orbit, or getting that safe transit into Venus atmosphere and back again.
And it also kind of begs the question again of, if there is a space station floating above the clouds of Venus, is it technically a space station, or do we need to change the definition yet again? So what do the rest of you think about a Venus space station?
Well, I think it would be a really good idea to have one floating on the clouds of Venus. I mean, it's the only other place you could survive with just oxygen. So you wouldn't necessarily have to have much protection. I mean, there's of course the sulfuric acid that would kill you pretty fast. But yeah, that would be a good place to start. And since it's closer to the sun, you could do science there, as well as you could actually look towards Earth to see any kind of asteroids between Venus and Earth. So yeah, I would go there, maybe.
Nut, what about you? What do you think?
I'm all for it. Exploring anywhere is good, so long as it's a step forward and not a step backward. That's where it matters.
Do you think that going to Venus would in any way be a step backward?
Not necessarily. I think there's a lot to be discovered on Venus. I think it's an important step forward, and we'll learn a lot about the history of Earth.
And Rich, what about you?
The scientific opportunities there is nice. You could almost have it as a kind of cautionary tale from a runaway greenhouse effect. You can study that. So not only does that have applications to help prevent or dampen the effects of climate change on Earth, but you could also take the same effects and apply them to terraforming efforts on Mars.
Interesting concept.
Venus rocks. I just think of Peter Beck now. As soon as I hear the word Venus, I think of Peter Beck straight away. I don't know why, but I'm thinking Mars is Elon, Venus has become Peter Beck, and they're the two guys that could make it happen. And I get really excited about the Russian stories about the lightning and how they're fascinated they were about recording that lightning with that first probe they dropped down on Venus. And I always thought, are we going to end up floating in the clouds, or are we going to end up inventing these amazing pressure suits that can hold, withstand maybe 150 bar or something that's like that? To go to Venus, the best thing for that, the science for that, would be the volcanic activity and understanding more about that in the solar system.
And now you're talking about the Venera missions from Russia, correct? Or actually, at that time would be Soviet Union, I guess.
Yeah, the stories of the pressure and the environment there, the heat and everything, it's like, forget about it. But it's like going to Mars or the moon. There's these challenges that are so individual with each part of the solar system. And it's kind of like, I'm excited about the plume worlds and the icy moons and the ejecta that's going on in Enceladus and all that stuff, and the water out there. I mean, who knows what's underneath the core, the crust of those moons and stuff. But Venus has a lot to offer in the sense of activeness. We can go there, it's close, it should not be ignored for sure.
The journey down to the Marianas Trench with Jacques Piccard, we had a submarine which could survive up to 1,000 atmospheres of pressure. Surely we can design something to get us to the surface of Venus to explore and see what that wonderful world can show us.
I did actually joke with Kage prior to this episode about creating effectively what's like a space bathysphere, because we know, bathyspheres have been used in deep sea explorations already, and they're used as return havens for divers, so they don't get the bends. So if we could design effectively a bathysphere specifically for Venus, that would actually be really good to explore within the atmosphere, I think, if we could get something that could withstand the acid.
But one of the problems, though, is that I don't think it's so much the surface pressure or the surface temperature as much as the... Well, okay, actually it is the surface pressure, that getting something down to the surface is not that hard. The Soviet Union did it, 12 or 13 times, I think, with the Venera missions. But the problem, though, is getting something back off of the surface. That, you have to think, when you launch a rocket on Earth, you have those call-outs for max Q, or maximum aerodynamic pressure, and that's where you have the most stress against the vehicle when it's ascending through the atmosphere. I can't even imagine what kind of max Q you would experience on a spacecraft trying to get from the surface of Venus through its incredibly dense and very, very tall atmosphere. The atmosphere is, I think, about 3 or 4 times taller than Earth's atmosphere relative to the surface of Venus, and it's so much more dense than Earth's atmosphere. So getting humans down to the surface might be the easy part. Getting them back off the surface, that would be a challenge at the very least.
So I have one final challenge for you guys. If I built a base on Phobos, orbiting around Mars, provided a space elevator to Phobos orbit, set it up as a refueling station, would that be a space station, or is it just a moon base?
I think we really need to think about what we are using as a definition for space stations in the future, because right now we have the definition of a satellite that humans can reside within, that is in orbit around something. But if we end up having a satellite that humans reside within that's in a Lagrange point, well, it is still technically in a form of an orbit, but not as much. Or if we have a space elevator between from Phobos, then maybe that is a new definition for maybe that's a new definition for a space station. And hopefully in the not too distant future, then we'll need to rethink our definitions for space stations as we become multiplanetary. And with that, I want to thank everyone for joining us for this episode of Becoming Multiplanetary, one of the podcasts on the Total Space Network. As always, you can check us out at TotalSpace.net, as well as on Twitter at TotalSpaceNet. And I will now hand over to my other co-hosts.
Hi, I'm Rich LB. Thanks for joining us on this week's episode of Becoming Multiplanetary. We're going to do something new this week for the outros. I'd like to actually say a big thank you to Jishwan and Sebastian, Gio Pagliari, Fremric, Susie R, and Marco for being our patrons. Thank you very much for your support. And also, if you want to help support the channel as well, if you like what you hear, you can find us at patreon.com/totalspace. Be sure to check our other socials as well.
I've been Mikko, the host of Deep Dive Fridays. Don't forget to follow us on Twitter, YouTube.
I've been AnotherSpaceNut. Thanks for listening, guys.
I've been Benno on Becoming Multiplanetary. The pleasure was all mine. Thank you so much, guys, for having me on the show. It was great to be here. I look forward to being on the next one. You guys take care out there. Thanks for listening, everybody.
I am Framric, and thanks for letting me be a guest speaker on the podcast today.
And thank you all for joining us once again. Really do appreciate talking with you. And you can catch us again next time on Becoming Multiplanetary. Have a great day.